Scalar or dot products. What is a scalar or dot product of two vectors? If A and B are two non-zero vectors, then their scalar product is defined as vector A dot vector B equals to magnitude of vector A into magnitude of vector B into cos theta, where theta is the angle between vectors A and B and theta lies between 0 and pi. If either vector A or vector B is 0, then theta is not defined and vector A dot vector B equals to 0. Now let's discuss some observations that will help you to solve various problems related to scalar products of vectors. According to the first observation, vector A dot vector B is a real number. This means that the dot product of two vectors is a real number. According to the second observation, if A and B are two non-zero vectors, then vector A dot vector B equals to 0 if and only if A and B are perpendicular to each other. This means that the dot product of two vectors is 0 if the angle between them is 90 degrees. According to the third observation, if theta equals to 0, then vector A dot vector B equals to magnitude of vector A into magnitude of vector B. In particular, vector A dot vector A equals to square of magnitude of vector A. According to the fourth observation, if theta equals to pi, then vector A dot vector B equals to minus magnitude of vector A into magnitude of vector B. In particular, vector A dot minus vector A equals to minus square of magnitude of vector A. According to the fifth observation, if I cap, j cap and k cap are mutually perpendicular vectors, then I cap dot I cap equals to j cap dot j cap equals to k cap dot k cap equals to 1 and I cap dot j cap equals to j cap dot k cap equals to k cap dot I cap equals to 0. According to the sixth observation, the angle between two non-zero vectors A and B is given as cos theta equals to vector A dot vector B upon magnitude of vector A into magnitude of vector B. Let us now discuss some properties of scalar products of vectors. According to the first property, the scalar product of two vectors is commutative. This means that if A and B are any two non-zero vectors, then vector A dot vector B equals to vector B dot vector A. According to the second property, the scalar product of two vectors is distributive over addition. This means that if A, B and C are three non-zero vectors, then vector A dot vector B plus vector C equals to vector A dot vector B plus vector A dot vector C. According to the third property, if A and B are any two non-zero vectors and M is any scalar, then M times vector A dot vector B equals to vector A dot M times vector B. So this is the whole concept of the scalar product of two vectors.